Now, in this version of COMOSYS, we've added a few more sections. So as you know, in the previous versions of COMOSYS, we had the symmetrical eye section in which both the flanges were basically the same. Their widths and their thicknesses were the same. But in this version of COMOSYS, we've added the unsymmetrical eye section as well. And what the unsymmetrical eye section means that the flanges can be different. They can have different widths and they can also have different thicknesses. Now, you can add these sections into your database from the Tools menu. If you go to the Profiles database, you can say Create New Profile, and you have this asymmetric eye profiles now. And you can just click on that and you can say Next and give the values, and COMOSYS will calculate the rest. But you could also now enter these sections directly without adding them to the database by using this notation over here, the parametric notation, which already you're familiar with. It starts with this at, and the difference is that it starts with, instead of I, it starts with IA, which means asymmetric eye sections. And then we have the H value, 500, the B value for the first flange, the S value, which is the web thickness, the T value, which is the first flange thickness, and then the second flange width and the second flange thickness. So by using this particular format, you can create the unsymmetric eye profile. Of course, as always, you can select it, you can press Control Q, and it will rotate like that. You can press Control W, and it's going to go like that. Control E will do will give you these offsets. Another profile which we have added to our standard sections list is the bent Z profile, which wasn't available earlier. Once again, you can add it from through the profile database, or you can add it parametrically directly from the dialog box by starting with the at as usual, and the ZB, which stands for bent Z. And then you have the H value, the height of the section, the B value, which is the width of the flange over here, the thickness of the section, the material thickness of the section. 65 is the length of this slip over here, from here to here, and 45 is the angle. You can change this angle from here as well. So a very easy way to now add the bent C profile. Another profile which we've added is the asymmetric Z profile, in which the flange widths are not the same. So the thickness remains constant all along, of course, because it's the same sheet being bent, but the width of the flange at one point can be different from the other point. And once again, you can add it through the database, or you could just enter it parametrically by saying, starting off with ZA, which means asymmetric Z, and then the height, and then this is the first flange width, then the thickness of the sheet. 65 is basically the slip length, and 200 is the width of the second flange. Now, as you can see, this being an asymmetric section, the center is not where the vertical web is, and you can, as usual, select it and press Control Q to rotate it, Control W to take it to the left or right, or Control E to take it to the top and bottom or the middle. Those are always available, but the standard middle orientation doesn't pass through the geometric center of the section. Another section which we've added is the sigma section. Once again, you can add it through the profile database, or you could enter it directly on the screen by using the parametric section. You start off with the at, and then you write SIG, it stands for sigma, and 500 is basically the height of the section, 200 is the width of the flange, 12 is the thickness of the sheet, which is going to be bent, 45 is the lip length over here, and 170 at the end. This height is 100, and the horizontal distance over here is this 70, which you need to enter like that. So by using this parametric configuration, you can enter any Sigma profile which you want. Another section which we've added in this version is the unsymmetrical concrete eye section with sloped flanges. And you can, just like the other sections, once again, your Control Q, Control W, Control E shortcuts, they all work. And the way to enter this section is obviously, once again, either through the profiles database, you can add it through the profile database, or you could just double click on an existing section and enter the parametric name for this section. Now, the parametric name starts with the @ symbol, as you know, and it's followed by the capital letters of I and C, I being the section shape and C referring to concrete. And then you've got several variables, as you can see. These are pretty self-explanatory. The first one is the height. The 1500 you see is the height of the section, the total height of the section in millimeters. The second one is B1, which is basically the width. This 1200, which you see over there, is the width of the top flange. And then there is it's followed by S, which is this 200 is the S, which is the thickness of the web, and that's followed by T1. This 200 is T1, which is basically the smaller of the thicknesses of the top flange. So it's not this thickness over here, but the thickness towards the end. 700 is B2, which is the bottom flange width. 200 once again being this thickness. And then you've got these two slopes, 0.35 into 0.35, the top slope and the bottom slope. This is basically the slope of this line. When you go 1 in this direction, how much do you go up? So when you go 1, you go 0.35 up. You can change these numbers and they'll give you different slopes. And of course, as you know, you can very easily, using either the surface macro or the manual commands for entering rebars, you can very quickly and very easily create rebars along this section and create your stirrups or basically any kind of reinforcement which you want. So a handy new section to have, and it's included with this particular version. Now, the fitting command in COMOSYS existed before this version as well, but we've improved it. As you know, the fitting command lies under the cut menu over here. This is fitting by a surface, and then we have fitting with 2 points. I'm going to show both of them. We've improved them. That previously you used to be able to fit one object at a time, but now what you can do is, let's say, for example, you've got these several elements, several frames which need to be fitted to the bottom of this slab, for example. You could just select all of them and go to your fitting command and click on it, and it's gonna normally it would ask for an element and then a surface, but if you already have several elements selected, it's going to directly ask for a surface. And the moment you click on that surface, immediately, as you can see, all of those elements have been extended and those fittings have been created. Those elements have been, so previously it was like, let me undo that. It was like this, and you just need to just select them, go in there, select your fitting, show a surface, and it is, the fittings are created. Now, the same command under the cut menu also exists in this other form in which you don't select a surface, but you select 2 points for a fitting. And this one now also works in the same way. So you could just select multiple elements, go over there, go to the fitting with 2 points. And in this case, instead of asking for a surface, it's going to ask for 2 points. So let me just go select from there to there, for example. And immediately those elements are extended and the fittings are created. As you know, the fittings have this variable, this handle, which you can then, if I wanted to give it a fitting of 20 millimeters, I can give it a further offset as well from that point. But that's the general behavior of fittings. But generally, the ability has come where you can now do a multiple selection and do a fitting by 2 points as well. So there's a nice feature which we have added which allows you to create and to change any surface which you can select on the screen into a plate. So although, for example, with tapered members, you could already actually convert a tapered beam into plates by using this command over here, tapered profile to plates, which would just allow you to just convert them into 3 individual plates. But let me undo that. So we have the profile again, but when we now have the command where you can basically just individually select a surface, this one over here, create plate on a surface. And just by selecting a surface, a plate will be created over there. And you can select another surface, and then you can select another surface. Let's say you want to select it from here. You press Control, you get the back one. You can create a plate over there, and then you can offset those plates to get them where you want. You could use it. You could use this command in more complicated situations. For example, if you wanted to create a cylindrical bent plate, you could just go in there and say, I want to create a plate on these surfaces. Let's say like that, and like that, and like that. Along any shape, basically any solid which you could import or create over here, and then you could easily, using the cylindrical bent plate command, you could easily join them together by just clicking on the plates individually. For example, you could do something like this. You could say this one, and then go in again, this one and this one, like that, and then this one and this one, like that. You could just join them all together and create your bent plate like that, and then you could get your 2D drawing, the unfolded 2D drawing directly like that. So a very useful feature to have, which basically converts any surface into a plate. One very nice feature which we've added in this version is to do with the creation of these closed polygons. As you know, these closed polygons are used extensively when you're creating, for example, extrusions or surface of revolution or things like that. And you basically create a closed polygon and some inner loops if you want some inner holes by selecting points on the screen. Now, so for example, you would go to the polygon command and maybe let's just create a simple square like that. And once you've done with that, you could go to your extrusion command over there, select the polygon, and then select the extrusion path, and your extrusion would be ready. Now, of course, the creation of a simple square doesn't take a lot of time, but when you're dealing with more complicated shapes, like, for example, a retaining wall or a retaining wall with a wedge over here, or maybe some hole in the middle, or some other complicated shape, then the creation of the initial polygon can be time consuming. So let me just undo that, this shape over here. And the feature which we've added now is that you can create these shapes once and save them away in a library. So for example, if you once you've created a shape, you can double click on that, for example, and we've added this tab over here called the polygon tab, which wasn't there before. And inside over here, you can save away any shape. In this case, it's a rectangle, but you could create more complex shapes. And you could save them away as presets like that. And you can create as many presets as you want. And then whenever you want to recall them, you could just, so for example, if I wanted to, I could just I created a simple square over here. I could double click on that, go to my polygon and say, oh, I don't want to use the square. I just want to use my ribbed retaining wall, for example. And the moment I say load, a ribbed retaining wall which has got a rib over here, is created as well. I could just go in there and say, no, I wanted the simple retaining wall, and I could just go like that, and it's a simple retaining wall now. Or I could have a simple retaining wall with a hole inside it, and if I say load, then it's got a retaining wall with a hole inside. So you could create as many shapes and save them away. in this way. And what that would allow you is to then use those saved away shapes, and then you could modify them. For example, if let's say the real shape which you encounter, let me go in and make this into a simple retaining wall, say load, and then when you're actually using it, maybe the particular wall which you're using has got a different dimension instead of 200, like that. And all you would really need to do is just move this edge and just this edge over there, like that, and press Control and select this one. And then you would all need to do maybe make it 250. So add another 50 to that, 300, and a little modification to the shape which you've already defined in your database, and then you can just use it to extrude in that direction, or along some other path. So this really gives you an advantage, because the modification of an existing general shape is a lot easier than entering the general shape from scratch. So what we've done is we've added this feature. You can now create a simple square if you wanted to, and then go to your library of shapes. Just load any shape which you want. Just say load, and it will be loaded, and then you can maybe make the hole bigger. If you wanted to, you could just go in there and select the sides of the hole like that, and say you could just make it bigger, make it shorter, make the whole retaining wall shorter like that. And then once you're happy with the shape, you could just extrude it. So very useful feature in which allows you to save these shapes as in your company environment file, and then use them wherever you want. Now, those of you who are familiar with COMOSYS will know that we have an existing folded plate command. And the way it works is by selecting endpoints, at least 3. And when you're finally done with selecting the points, you right click and a folded plate is created. In this version, we've basically created a different version of this command. So this new version of the command section, folded plate, lies just under the existing folded plate command. It's called folded plate with angle and distance. And unlike the other folded plate, which asks for n number of points, this one will ask for only a single point. And you will need to set your work plane before you use the command, because it works according to the work plane. But it's only going to ask for a single point. So I'm going to click that point now. And you see that the moment I click that point, let me right click and leave this command. The moment you click that point, it will basically create a folded plate for you with a standard input. Now, let me just double click on this one and show you what it looks like. It basically looks like the other one, but it's got a new type of input. It's got this data over here, and what this is saying is the first number is an angle with reference to the x-axis. So it says go 90 degrees from the x-axis and go a distance of 500 millimeters. So this is the first leg. This one is 500 millimeters. Then it says go 0 degrees according to the x-axis and go a distance of 300. So that's this leg. And then it says go 45 degrees according to the x-axis and go a distance of 500 millimeters. So if I were to now continue this, for example, and say go 0 degrees, and go another 250 millimeters, say apply, you'll see that a leg is added to that. Now, this idea is quite useful, because what this allows you now is to save this away as macro presets very easily. And once you save it away as macro presets, you can quickly recall many shapes which you have created. These could be the treads of staircases, for example. So, for instance, this case which you're seeing on the screen, this is just a few random numbers just to create a shape. But if I had saved away my presets, if I were to go in and recall a preset of type 1, it could be a stair tread, which saves away all the numbers required, and I just say load and I say apply. You can see that immediately it has created a step for me, which was saved away as type 1. And this one, it starts from this point. So let's see the numbers. the numbers are go 90 degrees, which means vertical, and then go a distance of 50, then go 0 degrees 200, and then 45 degrees 50. But if you notice, there's also this option of an anchoring point. So normally but the anchoring point is the first point, which means the starting point, and which would bring it in like this. But if I put anchoring point is 2, what that would mean is that although I'm defining the folded plate from this point, which I have to, but when I'm selecting the point, anchor it around the second point. So that makes my job easier because I'm going to select this point on the stringer. Furthermore, I can give it a further offset of say minus 30 millimeters in the X direction. And that's going to first anchor it according to the second point and then give it a shift as well. So this will really make my job a lot easier as far as creating the thread is concerned. I could, like I said, go back to this one and create another type 2, for example, just say load, say apply. And this one is a different thread in which the angle is not 45 degrees, but 90 degrees on both sides. Or I could choose type 3, for example, say load and say apply. And in this one, it's a different thread altogether because we have these little, this is how the folded plate has been defined. So this basically allows us to very quickly define many presets, many different type of threads, for example. That's one usage. You could have other usages. Anything which you do with folded plates like eaves, beams, or anything with sheet metal, which you do. You could give it a usage. You could call this a checkered plate or something else. You give it a material. You could give it a color, for example, and then save it away. And then your plate will be saved away. And then every time you want to use it, so for example, let's just recall type 1 type 1, let's say load, let's say apply, and then let's say set as default. Okay, and now you can basically go in again to the same command and just basically click on the points where you want the thread, or you could just copy the thread, obviously. But very easily, your all different types of threads would be created. So this is a very useful command. It's basically the same as the folded plate command, but it's very useful because it's a different form of input. It's a different style of input, which really makes your life a lot easier. It basically allows you to give angles and distances, and you can create any definition, save it away with a name, and then just recall it. Give it an offset from the original definition, give it an anchor point, and you're basically good to go. Now, one of the macros which we've improved in this version is the ladder macro. As you know, you can just click on the icon and click on a point, and you get your ladder, as you can see on the screen. As you can see, this is the style which was supported previously as well. You've got your cages like this. This is what it looks like from the side. But what we've done with this version is we've added a different style. So if you click on M, enter, as usual, we see that we now have this cage style option, and the default was the one which we already had. And now if we choose style 2, we get this new style in which you have an expanded cage at the bottom. So let's just apply that and see what happens. So this is what it looks like, and this is a different style to the one which we had. So what this leads to is also a different style of these vertical plates, which can then be previously these vertical plates would just come down straight, but now they have to be open, and you have the option to make it one continuous plate from here, which will be a folded plate like this, or break the vertical plates and then have a separate plate like that. Obviously, the input also changes. Once you choose the style 2, then you can have your cage thicknesses over here. First of all, you have the location of the first cage. You can enter that number over here, and then you have the location where the ladder broadens to open up. And over here, you've got the thickness of the cage. You got separate inputs for the middle cages, for the bottom cage, and for the top cage. And you also have input for the vertical strips over here. You can enter the number of cages because you have this distance, and then you also have the distance where it broadens, so this distance is known. And then you can decide how many cages you want to put between that area by entering a number over here and a number over here for how many cages you want to put at the top. Once again, you can choose the options for exit to the left, exit to the right, exit on the front. What we've also done is the ability now, previously it only supported the angle profile. Now what we've done is we've added the ability to use either angles as the vertical columns, or channels, or even just plain flat plates. These three options have been added, so you can choose those as your vertical profiles. Previously, the only thing which was supported was the angles. So this is a new option which will allow you to create vertical ladders a lot more easily when this is the style which you prefer. Now, one of the things which is done very differently in every part of the world is are the handrails. So we have a handrail macro, and it's quite powerful and it's quite flexible in many ways, but it has its limitations. And some of the limitations are the kinds of profiles you can use as the post. So there's there's to do a full proper handrail, the angle and the pipe options are supported primarily. And although you can have any other profile, but generally the connections will not then be made properly. It's basically supports for the angle and the profile. And when it comes to side connections, there's only one option of a side plate kind of a connection. Similarly, there are limited options for what you can do at the ends with the pipes. I mean, there's this one option which you see on the screen, and that's basically it. So you're limited with the profiles you can use. You're limited with the connections which you can use. So there are certain inbuilt limitations in the current handrail macro. Now, in this version, what we've done is we've started developing, and it's gotten to a pretty decent stage at the moment. We've started developing the modular handrail macro. And the modular handrail macro is different from the previous handrail macro in the sense that it's very customizable, and the user can actually add their own connections, and it's not limited to what kind of profiles you can use in it. So the way you use it is you basically just click on it, and then you just select 2 points, point 1 and point 2, and it's going to find the beam under that point. You don't need to select the beam. If there's a beam or there are multiple beams under that point, it's going to find it, and it's going to create a handrail for you by default. Now, the difference which this particular macro now has over the other one is, if you press M and enter, is that you have, first of all, obviously you have complete control over the spacing of the posts and everything. But the posts now don't have to be a single piece. If you want, you can break the posts at any point which you want. So you can have the post going from here to here, from here to here, from here to here. You can give, so it gives you more flexibility of how you want to connect the post to the top and to the middle, or to the bottom in general. Secondly, you can give these offsets, but the biggest change over here is that you have this option to select from many connection types, and these connection types can be increased as well. So if you create your own custom connections, then you can they can be added to this list, and you can. So basically, for example, if I were to give my post a let's say an offset of say -140, let's say like that, you will see that now it's shifted, and obviously you can't do the end plate connection, so it's you don't see any connection from the sides. But if I go back in now and click on M enter, instead of choosing the general end plate connection, if I choose the side plate connection and say apply, you will see that that connection can be supported from the side. and it creates a side plate connection once you've taken it to that side. But like I said, you can add options to this. So there's a post angle connection, for example, in which uses a folded plate, and you can use a folded plate to connect the posts from the side. Or you could use a post elbow connection, for example, which is something like this. Or you could do something like a fin plate connection, which would then create fin plates from the side. Or you could use a removable connection, for example, a removable handrail connection, which would, you'd have a pipe in which the other pipe, the post would go inside the pipe. It could be a pipe or a box profile. So, and as you're not limited to these, you can actually create your own connections for the side point and add them to the list. So this is something which gives you a lot more flexibility over how you can use the handrail macro. Then you can do by the same logic. If you go inside, you can break the handrails as well. First of all, instead of just having one handrail at the top, you can have multiple handrails. So you can give distances and create any number of lateral sideways going handrails over there, and then you can break each of them if you want at specific distances. So the basic idea of this macro is that this is now going to become a very flexible and customizable handrail macro, which users can then use anywhere in the world. They can create their own connections. They can add their connections to this connection list, and there will be no limitation of any profiles. Intermediate members, these are the intermediate members. Once again, there can be many layers. Once again, they can be both plates or profiles. You can break them from here to here, from here to here, and then save it all away as a preset and recall them according to your needs. End connections would basically be, the connections you make over here, this kind of thing over here. So this new system of creating handrails is very flexible. It's very general, and the basic thing we've seen with handrails is that every country does them differently, and every project may have its own specific requirements. So you can't have infinitely many handrail macros. What you need to do is create a handrail macro which is very customizable and very extensible, very extendable. And this is what we are attempting to do now, and it's gotten to a pretty decent stage. And you will be seeing the first version of this in this version of COMOSYS, and then we'll keep adding further customizability to this macro as well. And of course, if you wanted to do a very specific connection which looked different from anything available in the macros, and you also did not have time to create a custom macro for that, you could just do the detailing very quickly for one case and then use the very powerful feature of IntelliClone. Just select the elements created, making sure that the joint is also selected. That's the connectivity. And just go to your IntelliClone menu, say clone all. It's going to tell you that 6 other places are unconnected in the model. You just say proceed, and then everywhere in the model you will see that the specific modeling which you did has been completed. Now, sometimes base plate template plates are used at the site to ensure that the anchor bolts coming out of the foundation are perfectly aligned with the base plate holes. And to do that, what they do is they create a template plate which is in accordance with the base plate. It's the holes in that plate are exactly the same as this plate, and that particular template plate is then embedded in the concrete. So we have this ability now to create an extra plate. It's this macro over here called the template. You just click on it, and you basically just select any base plate, and immediately a template plate is created with the holes which are exactly in alignment with the base plate. You can give it a certain offset. You can make it slightly bigger than the actual base plate itself because you want to embed it inside the concrete, and you can give it a distance, how much what the size where you want to create this in the model. Doesn't really matter where you create in the model because this is basically going to be sent to the site. But this very nice feature now allows you to very quickly create template plates, which can then be sent to the site to facilitate the exact alignment of the anchor bolt. Now, another useful macro which we have included in this version is the shim plate macro. Now, you know that shim plates can be necessary to facilitate erection. And the way this macro works is that you can just, if you already have an existing plate, all you need to do is basically just click on this macro and select any plate, and then select a side, which is, could be on the back side of the plate or the front side. I'm just going to show it to you how it works. So you click on a point, and the moment you do so, it creates a few shim plates in there. And the number of shim plates is obviously depending on the input. And what you can do is, so for example, if I were to just show you, if I say show only, you can see that this shim plate takes the exact same location for the holes in diameter, which already existed in the original plate. Now, if I were to go inside the macro and open it up, you see that it says 2 into 2 millimeters. So that's why it's created two plates of 2 millimeters each. But this is the more interesting parameter over here, which basically allows you to do 1, 2, 3, 4, 5, 6, 7 different styles. The first one is basically the same as the original plate itself, but let's try this one. When you do that, you see that you get these slots in the shim plate. Now, the direction for horizontal and vertical will depend on the local work plane or the local coordinate system of the plate. So you might not always get the horizontal ones. So for example, in this case, if I were to say, okay, you see we get a vertical instead of the horizontal, but that's only because the longer direction is what defines it. If I were to just select it and say show only, then you get a slot basically, and you can reverse this, go back into the macro. So it says horizontal slots. But then you have the option of horizontal slots reversed. And if you do that, then it's the other way around, like that. If you show it only, basically to bring it from the top. And if I go back in, the other option would then be vertical slots finger, like that, or the vertical slots reversed, like that. And in this case, let's just go in and see what it looks like. So this is what it looks like. Now, the final option inside would be related to separate horizontal vertical. So let's do the separate vertical slots. In that case, you see that it's going to break the plate actually into 2 plates. So I'm going to select those like that and say show only. So it's actually creating 2 shim plates, one from this side and one from the other side, because sometimes it's easier for the people at the site to work like this. Now, this macro will work like this for any plate. You just show it a plate and show it a side, and it will create those shim plates for you. But you will probably be using it more from inside. So for example, this is the stiffen end plate macro over here. Inside the stiffen end plate macro and the other beam to beam or beam to column macros, wherever we had this option of creating shim plates, now this shim plate option has been expanded to basically call the other macros. So for example, if I were to create a shim plate of 2 millimeters, I can, by the way, say 2 into 2 as well, just like we did in the macro. Let's just create a simple one and do a separate vertical slots over here and say apply. You see that this the shim plate is created from the macro directly, like that. And let's go to the other side. There will be another one over there. So the macro itself now, basically the stiffen end plate macro is calling the shim plate macro from within itself and creating those shim plates for you. So wherever we have these existing, this option to create shim plates, those macros will now be calling this macro with all its options. But wherever it doesn't exist or you want to create shim plates manually, you can just use this macro directly as well. Now, one macro which was being requested by our customers was the staircase macro. Although we have all the tools to create staircases, but our customers wanted an even easier way of doing it. So in this version, we are providing the first version of the staircase macro, and it's very easy to use. You just click on it. It asks for a point. You can right click to choose a beam, and then it asks for a point again. Once again, you can right click to choose another beam, and then it asks for a point, and then what you can do is you can hover over any point and say, for example, DY 1500, like that, and it's going to create the staircase for you over there, as you can see. Now you can continue by right-clicking, choosing the beam, right-clicking, choosing the beam, and then hovering over that one and saying dy minus 1500, like that, and it's going to continue to create the staircase for you. It's going to also create the handrails and also the connections, so for example, if I zoom in and show you over here, it's going to create these connections on both sides. It's going to create, and you have an option of choosing which connection you want to choose. So for example, right now it's creating the beam-to-beam end plate connection, but you can choose, if you go inside the macro, you can choose any one of the connections from the beam-to-beam end plate, or the stiffened end plate, or the fin plate, or the angle plate, or a general end plate. You can choose those connections over here and over here at the landings. You have control over the size of the landings, the lengths. You can bring that length down to 0 if you want. The first landing and the second landing. You could directly, if when you have a 0, when you don't have a landing and you're directly coming out of a beam, you can give an offset of how much you want to shift that beam. You have obviously control over the gap between the stringers and the stair width, and you have control over the handrails as well. And so 3 individual handrails will be created, and once they're done, and these are created using the modular handrails, so they're very much customizable. You can go inside and you can change these settings according to your liking, or initially when you're calling it, you can call it with a particular preset as well. So for example, you have over here, so these are the connections over here, but as far as the handrails are concerned, you can choose from presets. You can create your own presets, and each one of those will be created according to those presets. And once, for example, you can align them to come on top of the stringers. So for example, if I were to do that, right now you can see that the posts are not really in the middle of the stiffener. That's the default, because it's basically following the line of the stringer. But you could go inside your handrail macro and just give a little offset over there, and when you bring it to the middle of the stringer, your connections will also be created. And you can, like I said, you can make these, you can customize these to some other connections. All these connections are available. If you bring it further on to the side, you can create a side connection. And so it's very flexible. It also gives you control over the stringer holes macro, for example. So this one is calling the stringer holes macro, so you can see what kind of steps are going to be created, whether it's going to be grating or checkered plate, or you can give the details of that connection as well. So very customizable. You have control over the handrails, you have control over the treads, you have control over the landings, and you can very quickly, like I said, just by selecting points, you can go up your staircase. So very convenient way now in this version to create your staircases along with handrails and treads very easily. Now, in COMOSYS, there are 2 ways to create assemblies. And the primary way to create an assembly is to create a weld between objects. So when you weld two objects to each other, they become an assembly. Now this, what you're seeing on the screen right now, does not have any weld in it. So if I were to select this beam and right click and say select assembly, only the beam is selected. This plate, only the plate. This plate is also separate. There's no welding connection. The other way to make something an assembly is through the use of workshop bolts. Workshop bolts will also bind two objects together to form an assembly. Now, in this version, we are introducing a third way of creating and modifying assemblies. So, for example, right now there's no assembly. These elements, these plates and bolts, and these plates and these profiles are not making an assembly. But we are introducing a new way in which you just select any number of elements on the screen, and you right-click, and you go to this new menu over here called the assembly menu, and you say Make Assembly. And when you do that, without having the need to create individual welds between all these objects, you will have created an assembly. So for example, if I were to now select this beam and say select assembly, you can see that it is now an assembly. Once you've created the assembly, you can of course modify it. So for example, if I were to select these two plates and right click and say go to the assembly menu and say remove the selected from the assembly. If I do that, then now if I go back into my assembly command, you will see that those two stiffeners are not selected because they were removed from the assembly. I can once again go and remove these end plates as well, or let's just remove the entire haunch from the right hand side. Right click and say assembly, remove the selected from the assembly. Now if I were to add say select assembly, only the main beam and without the stiffener because that was removed earlier, and this right hand side is you can see it's part of the assembly. And once if you want to add some things back, you can all you need to do is just select them again, select these parts which we had removed, go back to the assembly menu and say add the selected to the assembly. And once we do that, we just need to show it the original assembly, and that would be it. And now if I were to select the main beam again, say select assembly, all the objects are now part of the assembly. So this is now a third way of creating assemblies without having to go through the process of linking every element through the weld object or through the bolt object. And another capability which comes with this version is that previously we were unable to create welds or create this assembly connection between rebars. And now it is possible in this version. You can actually include rebars in your selection, and those rebars will also become part of the assembly. And finally, we come to the end. That's all from me today. I hope you liked what you saw. Please don't hesitate to contact us if you want any information. You can contact us directly or our resellers, depending on the region you belong to. As I had mentioned at the start, there will be some surprises for some lucky customers. We will contact you if you are one of those. Thank you for attending, and now we'll move on to the question and answer session.